Okay, so now let's try this example also. So with this example, we have to prove that the series 1 plus 2 plus all the way to plus n equals the formula n multiplying n plus 1 in brackets divided by 2. So let's see how we are going to prove this. So for us to be able to prove this, we will first have to test for the formula whether it is valid for some values of n. Okay, so this is called the base or that's like the base step. Okay, the basic step. So with the basic step, we are going to consider n to be equal to 1. Okay, the n values refers to positive integers. So that's 1, 2, 3, 4, and so on. So first of all, we are going to consider n to be 1. And then we will use it to test for this formula here, whether it is true. So when I take n equals 1 here, then I'm going to take the first term in this series, which is what? 1. Okay, so when I take 1 here, then I'm going to equate it to this formula, then substitute the value of n, which is equal to 1 in the formula, and then see if I'll get the same value as what this one here. So let's do that and see what I was talking about. So since we are taking n to be equal to 1, then we are going to take the first term in the series, which is what? 1. So we are going to say that 1 equals what? The formula n to bracket n plus 1. By this case, we are taking n to be equal to what? 1. So that was 1 multiplying 1 plus 1. Okay, all divided by what? 2. So this will be equal to, when I deal with what's in the bracket first, 1 plus 1 will be 2. So then I have what? 1 multiplying what? 2. All divided by what? 2. So this will give me the value of what? 2 over what? 2. And this will be equal to what? 1. So therefore the formula is true for what? N equals 1. So let's test for n equals 2 also. So I'll take n to be equal to 2. So when you consider n to be equal to 2, you are going to consider the first two terms in the series, which is what? 1 plus 2, which is equal to 3. So that will be what? 3 equals, then substitute 2 in place of what? N in the formula we have on the what? On the right side. So that was 2 multiplying 2 plus 1. Okay, all divided by what? 2. Okay, so when I sum what's in the bracket first, that will give me 2 multiplying 3. Okay, all divided by what? 2. So this will be equal to 6 over 2, which will give me what? 3. So the formula is true for what? N equals 2 also. So since the formula is true for some n values 1 and 2, we can't keep proving whether it is true for any of the n values, since n values refers to what? Positive integers. So you can't keep proving for any of the positive integers. So you have to find a general way to say that this formula is true for what? All values of what? N. So let's look at how we are going to do that. So I'm going to free up some space so that we continue with it. Okay, so now for us to be able to prove for this formula, okay, to be true for all n values, we are going to consider n to be equal to what? K. Okay, I'll consider n to be equal to k. So I'm going to substitute k in place of n in this what? Formula here, or in this what? Series here. So that was, the series will become 1 plus 2 plus all the way to a certain value k. Okay. So this should be equal to k multiplying what? K plus 1. K plus 1 all divided by what? 2. Okay. So we call this what? The base case or the basis. So I'm going to assume that this is what? True. Okay, so let's assume that the base case is what? Is true. So if that's the case, then we will set n to equal to what? K plus 1, which will be the value that follows k. So that means that if the formula is true for k, then it must be true for the value that follows what? K. So let's see how the series will become. So we have the series to be 1 plus 2 plus all the way to a certain value k, and then plus k1. That's k plus 1. Sorry. So this should be equal to, so in this case, I'm going to substitute k plus 1 in place of what? N. Okay, in this formula here. So that what? K plus 1. Okay, multiplying what we have here. That's also what? K plus 1. But you see that you are going to add this 1 here to it. Okay, so I'll just add the 1 here to it. K plus 1. Bracket closed. You can choose to indicate just this k plus 1 in the different brackets. So let's look at that. So you can write this k plus 1 in a different bracket here. Okay, so that it will not confuse us. Okay, so all this divided by 2. Okay, all this divided by 2. Okay, so what happens here is that looking at this side here, okay, you can see that what you have was 1 plus 2 plus all the way to k here. And then looking at the base case, we know that was 1 plus 2 plus all the way to k equals what? K multiplying k plus 1 in bracket divided by what? 2. So instead of using all this side here, okay, you can come and substitute this formula in place of what? This side, since this place is that what? 1 plus 2 plus all the way to k equals what? K multiplying k plus 1 in bracket divided by what? 2. So you're going to substitute this part in place of what? This. Okay, so let's look at what that would be. So you have what? K multiplying what? K plus 1. Okay, all divided by what? 2. All this plus what? The k plus 1. That's what? K plus 1. Okay, so this should be equal to k plus 1. Okay, and then simplify what's in the bracket. That what? This k plus 1 plus this one here. So that what? K plus 2. Okay, so that will be k plus 1 multiplying what? K plus 2. Okay, so I added this one and this one. That gave me these 2 here. So I'm multiplying the 2 brackets here. So all divided by what? 2. So what happens here is that if you're able to prove that the left hand side equals what the right hand side, then it means what? The formula is true. Then it means the formula is true. So let's prove whether the left hand side is what? Is equal to what? The right hand side. Okay, so now let's continue. So I'm going to write what I have on the left hand side here. Okay, so that was k multiplying what? K plus 1. Okay, divided by what? 2. Okay, plus this k plus 1 here. Okay, so I'm going to rewrite this in a different way. Okay, by bringing bracket in, then multiplying by 2, and then dividing by what? 2. This is the same as what I have here, because 2 divided by these 2 here. These 2 cancel out these 2, then you still have what you have here. So it's the same thing. So this will be equal to k plus 1. Okay, multiplying what? K plus 2. Okay, all this divided by 2. Okay, so what that happens here is that when you look at this, you can see that what all the denominators are the same. Okay, so you can even leave the denominators and then focus on the what? On the numerators. So focusing on the numerators, I have what? K multiplying what? K plus 1. Okay, plus 2 multiplying what? K plus 1. Okay, this should be equal to k plus 1 multiplying what? K plus what? 2. Okay, so looking at this side here, this is like factorization. Okay, so you see we have what? K plus 1 common to both sides here, and you have what? K plus 2 here. So how can what? It's like we have distributed the k and the 2. That's like one bracket multiplying the other. So if I'm to rewrite this, I'll rewrite this as k plus 1, okay, multiplying what? K plus 2. Okay, it's like you've multiplied this bracket here, okay, with this here. That's what gives us what we have on top here. So you see that what now on the left hand side we will got what the right hand side. Now so it's k plus 1 multiplying what k plus 2. So now the left hand side equals what the right hand side. Then you have proven that what the formula here, okay, or this statement here is what is true for what all n values, which is what positive integers. So now you've proven that what this statement is what is true. So this is how to prove for such questions. Okay, so if you're asked to solve such questions, this is the step that you use to solve these questions. Thank you very much for watching this video.